All right. Thank you guys for coming. This is a culmination of over a year's worth of work, most of it done by my daughter Emily. We started this whenever she was 13, and it's basically after hounding Sam and Johnny Long for months and months and months and months, we finally started doing something about it. And thanks for coming. So, this is my daughter Emily.
So, I love nature photography, and I take like 50 pictures every day. Most of them the same object. I'm 14, and I have a sister and a brother, and I'm a Christian.
And the last line is really how we got in this line of work. So just so you know, if you're wondering. I'm Branden Miller. I'm just a pajama-wearing hipster. I love drinking hot cocoa and talking about healthcare with my family at Christmas. And I love my onesies. I'm an analyst. I do that not because I'm really good at it. It's because it pays the bills and I like to shoot. And being a decent analyst makes me a lot of money so that we can shoot a lot. So we shoot as a family. Obviously, I'm a dad, husband, and I too am a Christian. So what this talk is not, it's not groundbreaking. We as in, once again, she, if I say we or I, just assume I'm talking about my daughter. This is more of a growth experience for us. We pretty much wanted to do something together. We homeschool, and in doing so, my wife and I are responsible with coming up with a lot of our own curriculum. Obviously, we don't, do our own math, because that's been around for a long time, but we do our own sciences a lot of times. Once again, it's not groundbreaking. Everything that we've done, we'll give you links to so that you could do this yourself. One of the things I always tell people is you don't have to go to Africa or South America or Russia to do good. You can walk out front of the hotel and start doing good. So one of the initiatives that I've been discussing with a friend of mine that goes to church is actually doing something like this just at a local after-school program targeting Hispanic students. The Rachel system is also in Spanish, so it's really nice. But he focuses on migrant workers in the Lexington, Kentucky area, so that's where we're from. And for us, it was a call to serve. So a little bit of background before we get into the technical stuff that my daughter's going to talk about. My daughter got her first camera in 2005, and that's her in the pink. It was a little Barbie camera. It took about 15 pictures, and she outgrew that camera within a couple of days. Like she said, she will take multiple pictures of the same object to try to determine what lighting is best and how best to do this. She started doing that at age 5. So we knew we were kind of in trouble early. It was going to be an expensive endeavor. And the next year, or the next summer, my family, my in-laws, all went on a mission trip to Uganda. Uganda's on my brain. I've been helping these guys with their booth lately. To Kenya, the Rift Valley area of Kenya, to do a medical mission trip. That's my father-in-law. Whenever they came back and they started telling about their experiences and their stories, Emily, who at that time was age 6, declared that she's going to Kenya. So we had to actually explain to her how a 6-year-old can't go to Kenya by herself. So she agreed to wait a couple of years. So about 6 years later, this is my mother-in-law and a physician that we actually helped put through medical school. And her name is Grace. I always get names wrong because I haven't actually met these people yet. That's next year. So Grace started a clinic. She named it Somerset Medical Clinic. And that's kind of her saying, hey, thanks to the town of Somerset, Kentucky for helping her. And thanks to my mother-in-law since she was from Somerset. It's not hard to finance somebody for medical school in Africa. It costs about $2,500. So we think of medical school as a couple of $100,000. Yeah. So whenever they came back, obviously they told more stories. Emily continued to complain that it's, her time to go. Why are we holding her back? And finally, in 2012, we didn't take her. But what they did was they adopted a school. Before, we cared for the clinic and an orphanage. And now we've adopted a school. It's a Maasai tribal school. And literally, this picture does not do justice to the isolation of the school. You drive for 2 hours. Yeah, you just drive for hours on goat paths and cow paths and washouts like streams and such.
Or
and then
just
all of a sudden,
across the field.
or just across the field, yeah. And there's a school out in the middle of nowhere. And it's, like I said, a Maasai tribal school. And it has about 200 students, so we've adopted this school.
When I finally got to go, we had found this like orphanage school thing. What was it called?
I don't know the name.
No, whatever.
It's an orphanage, but they can't afford to send the kids to school because in Kenya you have to pay for public school, so they homeschool.
Yeah, and so we were gonna build them this little room for them to use as a school, and they ended up actually putting the girls in there to sleep because it was the nicest building in the entire neighborhood.
So whenever she came back, she said, I don't want to just do good and go to Africa, but I want to be an artist. And I'm not an artist. I know nothing about art. Someone once said, you know art because it looks pretty. I don't think any of the stuff that I ever see looks pretty, so it's not me. So my goal was to divert her attention, and that's whenever we started the actual build. You want to try to take this? Okay. Emily got a lot of frustration out of this process because, like I said, I didn't do hardly anything. I made her do just about everything. But basically what we did was I built an XBMC server as a proof of concept and to keep whenever she went to Africa. So this is what Emily actually built me. We used the Raspberry Pi board and, $35, Wi-Fi dongle, and of course put XBMC load on it. We still run this as a media server in our house. But we installed Windows 7. What's that? Oh, yes, mention the Lego case.
Oh, yeah. So, I stole his really nice case to take to Kenya and to say sorry. I built him this really awesome Lego case. And
she discovered Lego CAD. If you've never dealt with Lego CAD, it's wonderful. It's really good. So we had 2 laptops that were donated to us. One of them was a Lenovo ThinkPad. I made her do a fresh install of Windows 7 so that she could understand our daily anger if you've ever loaded Windows operating system. And then for Linux, on the Chromebook that we had, we actually installed Crouton. Has anybody ever used Crouton? It's wonderful. Say you have a Chromebook, right? It's running Chrome. You install Crouton. It allows you to put just about any build of Linux on there that you want. And what it does is it actually allows for you to quickly, without rebooting the system, go from OS to OS. It's literally a keystroke, and it's almost like VM where it suspends one and then it brings up the other one. So it's really nice. Then the next part of the plan was for her to go to Kenya. I was wanting to go, but it didn't work out. My wife went instead. Install this learning network in the school or the orphanage. Emily was going to teach the staff, which was probably the other frustration we had, and we'll talk about that in a minute. And then our ultimate goal was just to talk at ShmooCon. It was more my goal, I'll be honest. I've submitted to ShmooCon year after year after year and never got selected. So I submitted Emily and said, basically, I have to go too because she's a minor, and they let me go. I finally got my ShmooCon ticket. So how it actually happened.
so, wait, what's his name, Sam?
Yeah, Sam. Sam, say hi, Sam.
Hi. He basically followed him around and was like, you tell me how to do this. And something like that. We bought the Raspberry Pi, built the XBMC server like we were going to in the first place, built a Rachel Pi, went to Kenya, built the little school building that they ended up using as a house, installed Rachel Pi, taught the staff, and then we got to speak at all of these. We got to speak at ShmooCon Marshall University, Aid, Lexmark, and yeah.
Circle City. Emily is actually a professor now, so if you want her services, just let us know. And then, you pay for travel. We'll show up and talk about anything. But yeah. So these are the steps to build a Rachel Pie. It's really simple. If you just go to worldpossible.org and follow 6 easy steps, you too can be a master engineer. But basically, you just buy it, you put it together, and then you flash the software. That's it. So if you can do these 6 things, you can have an educational server that you can deploy. So I was really proud of Emily. She actually set a budget for herself of $100 to do this. She raised almost $2,000, but the bulk of it was to go towards a good generator. The school and the orphanage both have generators, but they're horrible. Tell them a story about the popcorn maker.
Yes, so we were going to go to the school and make them popcorn. I was like, hey, we are here and we're going to give you popcorn type thing. So we went to make the popcorn, and the little light that heats the tin thing, sorry, that's really bad explanation, but it just kept flickering and turning off, and then you get like 2 kernels to pop, and then that's it, and then the generator just flew out.
So that's what she wants to do with the rest of the money. We basically paid about $88 for this particular build. Once again, I built the XBMC server. She built the case for me. Or I say she did all the work. The only thing I did in this whole process was actually download the Rachel Pie software. Now, it's a 32 gig build, but Hackers for Charity actually has a 64 gig build, which provides a lot more offline content. If you don't have a good connection, you can still operate a school. So it's really nice. That's the build that's on our Pelican Pi that we're going to bring back. She installed the OS.
We stayed up till like midnight trying to make this thing work. So that's how come I'm in the pajamas. And he wouldn't let me do anything except just watch it. And whenever it was ready, I had to go get him. And he was like taking a nap and drinking coffee, and I was just sitting there watching the screen. I was just like, when is this going to be done?
So we basically put it all together. This is kind of the whole kit. One of the things I made her do was brainstorm and try to figure out if something goes wrong, what do I do? Because once again, I wasn't going to be in country, and my wife knows how to turn on her computer most days, so she wasn't going to be of much help. Emily went to Kenya without me. Once again, I was supposed to go. I'm not bitter at all. This was the actual, this is where the boys slept. So what they did was on the outside of the house, they took anything they could to make walls and a ceiling. They put it together, and the boys slept there. The girls slept inside the house. So they built a school. And this is the completed school. And once again, like Emily said, once the owner saw the school, she basically said, this is the best building in the neighborhood. We're going to use that as the dormitory for the girls. We'll hold school in the house. Emily tried to make it work, but she realized that this building they were in didn't have power. Once again, they had a generator. That doesn't really work well for extended periods of time. So she went to the van. I was really proud of her at this moment. Proud daddy moment here. She decided the van has electricity. Let's go to the van. Problem with vehicles and things like voltage regulators in vehicles over there is they don't put out a sustained power level. So she couldn't get the Rachel Pi to work. So what she did was, one of the people that remain in just outside of Nairobi, Kenya at all times and helps us is this lady. And she actually is the manager of a Western style hotel. And so what she does, she goes out to the orphanage sometimes twice a week. And she's kind of our liaison right now. She runs out our medicine to the orphanage. And anytime we send her something for updates or whatever it might be, she does that for us. And then the best part.
We got to go on a safari. On the first day, we saw like 5 million different animals, and now I'm just like, whenever somebody says, I went to the zoo, I'm like, good for you. Literally, like, this, I didn't even zoom in. Like, this was literally how close it was. Just a, I don't even know, some kind of Canon thing my grandmother got me.
Canon D6, if you know anything about cameras.
And there was a leopard in the tree, and it, like, followed us, and it was fun. And just some lovely little things.
So the lessons learned were, number one, Rachel pies are easy to build. I made Emily install all the drivers manually, which was a mistake on both of our parts. I wasn't thinking about that one. She has become an excellent user of Google as a resource, so I'm proud of her on that. If you go to worldpossible.org and you use their parts list and their build list, make sure you use exactly what they recommend, because then you won't have to load drivers manually on a Linux system whenever you didn't know what a prompt was or a command line is. So, and they recommend a 1 amp power supply, but if you're using wireless, you really need 1.5 amps or more, because the dongles draw a lot of power. More lessons learned. It doesn't work on dirty power. The next build that we're taking is actually a Pelican Pi, and this isn't the one. This one HFC was so gracious to let us borrow because I left mine in the garage. But it has power in, it has about a 12-hour battery, and it actually has a solar panel. So we hit that mark. We still haven't bought the generator. We'll be doing that whenever we go back. Always have a backup plan. And Emily discovered that Linux for new users, even just if you're operating it, you know, you're not doing anything, you know, as a system administrator, was a little bit too difficult. Well, actually, a lot difficult. Even Grace, the lady that manages the hotel, who knows IT, had difficult times with it. So we basically just left the Chromebook as is. Didn't even show them how to use. We as in she. So we spoke at ShmooCon, and we thought that was going to be the end. That's us speaking. That's me, finally at ShmooCon. And my daughter, of course. And then Johnny Long came up on stage. And this was significant because, number one, he's Johnny Long. And number two, he gave us the Pelican Pi with one condition. Emily had to finish it. So that was really cool. So this is Sam. Sam spent a lot of the night, definitely the afternoon, building or helping build. He made Emily do most of the work. So what's next? This is really kind of our last slide. We're about to wrap it up. We're going in June to Uganda first. We're going to be the basically whatever Johnny tells us to do, we're going to do while we're there for a week. And then we're going to go to Kenya, and we're going to follow up. We have 5 goals. Number one, we're going to visit the orphanage that we support. We're going to be there for 2 days at least. We're going to do some modifications to the building. We're going to install their generator, and then we're going to replace their Rachel Pi with the Pelican Pi. Number two, we're going to go back to the Maasai Tribal School, and we've actually got a student identified there that is going to be our focal point. He's equivalent to a junior. He has the respect of all the kids, so if he tells them or asks them to do something, they do it, more so than a lot of the teachers. And he's just, from what my wife was telling me, he just is a sponge for knowledge, and he loves doing things with his hands, so he's going to be our guy. Once again, Emily wants to buy a generator. We're going to provide more computers for the kids in the orphanage. We left them the 2 computers. Lexmark actually donated 6 computers. Emily spoke there, and they basically said, one of the managers said, "Come to my desk. We want to give something to you," and it was 6 computers. That was nice. I was talking to a friend of mine. Go ahead. Yeah.
Guess who got to carry them all out to the car?
The purpose of this is a learning experience from our beautiful daughter, right? I was talking to a friend of mine at A&RC Services. They have a booth upstairs. I have to do a shout out for them because whenever I said, hey, you know, Lexmark actually gave us 6 computers. He said, I'll one-up that. So he gave us 6 computers too and some other stuff. So it's really nice. And then once again, we're going to replace the Rachel Pi with the Pelican Pi kit. And I hope to get a brick. Johnny talked about the brick earlier. I don't know exactly how I'm going to use it. I've been talking to Sam, and Sam's going to give me a lot more pointers. Here's our resources, so you'll be able to see everything that we did. This is basically what Emily used for all of our builds. And then last thing, I want to bring these guys up. You want to talk about the brick a little bit more, just in case somebody didn't hear about it? Johnny Long, Sam Kinch.
Let's not applaud for us. Let's applaud for these guys. They did a great job. I have to say these guys because then we don't put the whole focus on her. And
Yeah, I know.
Make her totally embarrassed, right? So, as I put the focus on her. I was just really blown away by this story. Obviously, I thought it was really cool that, first of all, it was a father-daughter project. It involved a bunch of different levels of technology, right? Everything from Fozzie's, level being in the industry, sort of understanding how things work, training his daughter, who's sort of new to the industry, to the folks that are in Kenya that had, he said she was involved in IT, but that doesn't necessarily mean a whole lot, all the way down to the students with zero technical knowledge, and kind of pulled it all together in a project that's designed to put a virtual library in a school filled with knowledge. This just operates on every level. And I thought that was one of the things that really struck me about the project. So some of you might be looking at this and might be interested in this and thinking, well, I don't really want to go to Kenya. I don't really want to go to Uganda. Isn't there stuff that we can do? And the answer is absolutely. There's lots of problems with all the solutions that we have. Everything's from the Chromebooks to the Pelican Pi to the brick, which I'm going to talk about. And we need people that can help us in that arena from right where you are. Just plug in and give us suggestions. And of course, there's always room for people to come on trips. The Pelican Pi is really great. This is what they're going to be taking to Kenya. I think you said it was in June.
Yes.
You guys are going and coming to Uganda with that. And it's a great project because these guys are understand it and they built it and they put it together and they can troubleshoot it. They mentioned the brick, and the reason that we're looking at the bricks is because in some cases, these things are going to get in the hands of completely non-technical people. And the brick is great because it's a smaller version of the Pelican Pi, which you basically just, you hit the button and the little lights come on and it communicates with colored lights what's going on. And now we have a web server, but it also is an internet router. So we can communicate with this thing through the cloud and actually see what's going on, look at configuration logs. We can even reflash it from the cloud. So the benefit of this one is if you're going somewhere and you're putting it somewhere and you don't ever want to see it again, or you can't, you can always, sort of call back in and get things fixed. Whereas this is really great, like as a maker's project where you're going to be in and out and visiting them and, you can get in there and fix things. Whereas this, once it gets bricked at $200, you could probably just buy another one and put it in its place. But sort of different variations on the same theme. But again, it just pulls everything together. And I think it's just a great example of the community coming together and seeing all those different levels really represented. So thank you guys for the work that you did. I want to bring up Sam for a second if you have anything to say. Sam's the one that kind of started the ball rolling with our prototype. So especially if you guys have any very technical questions about these setups, he's the guy. Sam?
Sure, thanks. We only have a couple minutes, but one of the things I want to talk about was the Raspberry Pi itself, the rugged Pi that we have here. It was a great idea, it's a good prototype, and it works really well in the field. The problem is when it breaks. And that's the big issue we're dealing with, and that's why the brick is so important right now, is because when this breaks, and it's 12 hours away in Kenya, and the nearest person is Johnny or somebody else who has to drive there, spend a whole day getting there to service it, that doesn't work for us. So finding something that we can remote into, fix on the fly, is money, and that's going to be huge for us in the future. And that's what we're trying to do, and that's why we partnered with Brick in trying to come up with a solution now that not only takes the remote capability that we have, but takes all the content, and it actually has the ability to remote upgrade. And like Johnny was talking about, the remote management is huge. it also gives us statistics too. And it's really nice for us to be able to come here and go, hey, look, this is what we currently have in the field, or this is the number of users that we've serviced or been able to service over the last 5 years. Those are the types of statistics that are going to be huge for us in finding out whether this is really worth our while. We know it is, we believe it is, but showing it to other people, having numbers and having locations on a map and saying this is where we're deployed, this is how far out HFC has gotten because of you guys is huge. So thank you. At this time, we can take a few questions. Sure, in the back. Right. So the brick is USB powered. You could, yes, actually, the question was regarding solar power and being able to actually power the brick and how we were going to do that. Yes, this rugged Pi does have the ability, because of the solar charge controller on it, to take in a 6-volt solar panel and charge it. The brick doesn't have that, but it does have USB powered connection, so that yes, if you could take this traditional solar situation, there is 12-volt solar panels on a mud hut with a battery. As long as you can take that battery and a 12-volt converter down to 5 volts, or they have the ability to, which most of the places do, because most of them are using those 12-volt panels for 1, for lights, and 2, to power their cell phones, to charge their cell phones. So they already have the 5 volts most likely. So that's not really going to be an issue, I don't think. We're more focused right now on the product. There's so many solar solutions out there for Africa. I think that's a best way to focus our efforts.
Yeah, and I'll also mention that's a really good point. The other thing that I'll mention is that this was designed in Kenya, so it's exactly where these guys are. So specifically for Kenya, if they have problems, it's very close to being able to get it fixed. Interesting story, when these things were being developed, there was a rolling power spike going through the capital city of Kenya, Nairobi. And of course they're on 220 power, and the power company got a couple of their wires, crossed, or however that works, and the entire city went to 400 volts. Merry Christmas, we're going to double your power, you pay the same price, we're going to give you more. And so in the middle of designing this, they were blowing these things out, their prototypes. So they fixed the power supplies on these things to accept up to 400 volts. So everywhere from 5 to 400 should pretty much be okay. So whereas I wouldn't plug this thing into the wall in Kenya, because I want to kind of be nice to it, this thing we can plug into wall power or into like a cell phone charger or anything in between, which really helps out a lot. That's a good question. Anybody else? So the question is basically about the geography, and the pictures are showing it in flat terrain. There's a 3G SMA connector here, so you can put an antenna, and the question is how well is it going to work in those environments, and it's really a factor of what kind of antenna you connect to it. Right out of the box, one of the downfalls of the brick is that it does not have a Wi-Fi connector. It doesn't have an external Wi-Fi connector, so it's not going to throw Wi-Fi very far. But the 3G connector on SMA really lets you pull in a signal from very far away. So in terms of pulling in that internet signal, let us get cloud coverage, any range of antennas, powered, unpowered, will really boost this thing significantly. Go ahead.
All right, so we're actually got the pull sign, so we're going to wrap this up. Do you have any more questions about the brick or HFC? They have a booth upstairs. I will be walking around all weekend. My daughter's going home, so... I do have to shout out to these people. HFC for giving us the idea and the support. ANRC and Lexmark for giving us our computers. We have 12 computers now. Emmanuel Baptist Church in Lexington, Kentucky. They're the ones, we have a lot of engineers in my Sunday school class from Lexmark, so they're helping me out. And First Baptist Church of Somerset, they're the ones sponsoring all of our travel. And then Appalachian Institute for Digital Evidence at Marshall University gave us $2,000 to start off our savings for this next trip in June. So thank you.
Yay.